Today we're going to be talking about the selection sort. More specifically, what a selection sort is, a visual representation, how it works, and finally the C++ program itself. A selection sort is ideally for small lists. Let's say you had a list of people that were going to come to your party, about 10 people. A selection sort would be good for ordering these people by age or by name. However, if you had a list of about 10,000 people, or maybe even 10 million people, it would take a long time. It compares the current element to each unsorted element in the list, and it's quite simple to understand. Let's start off with a video.
So here we have 5 unordered cards. We're going to use these cards to demonstrate the selection sort. Let's start off with the first term, number 3. We're going to compare the number 3 to the rest of the terms in the list. If we happen to find a lower number, we're going to stick to that number and continue our search down the list. Once we reach the end of the list, the number that we have stuck to is going to be our least greatest number. This number is going to move to the back of the list. So let's start. Here we have number 3. We're going to compare number 3 to number 2. Since number 2 is lower, we're going to stick to this number. Now we're going to compare number 2 to number 4. 2 ends up being less, so we're going to stick to number 2 once again. We move on to the next number, 1. Since 1 is less than 2, we're going to now stick to 1. And since 5 is greater than 1, we're going to stick to 1. Since we have reached the end of the list, we're going to take the number we stuck to, which is 1, we're going to take that number, and we're going to push it at the back of the list. We can now lock in this number, knowing it is the least greatest value. We'll start again from the beginning of the list, 3. We compare 3 to number 2. Since number 2 is our least greatest number, we're going to stick to this number and we're going to continue on the list. 4 is greater than 2, so we ignore it. 5 is greater than 2, so we ignore it. And now we notice that 2 is the second least greatest number in our list. So we're going to pull it out and lock it in, because we know it's the second least greatest number. And let's move on to number 3. Since 3 is less than 4, we ignore it. Since 3 is less than 5, we ignore it. So we lock in 3, and we keep on doing this until we get our numbers in a perfect order.
Now that we have seen that video, let's start talking about the code, or more specifically, the pseudocode. In this pseudocode, we have an array A and an integer n, which is equal to the length of the array. We have this for loop here, which is going to track I being the index number of the item we're looking at. We're going to also have an integer small sub, which is going to be their placeholder for I. So instead of using I, we'll use small sub. Inside this for loop, we have another for loop, which we're going to use to track j, the index number of the item we're comparing. So if we're looking at the number 1 and we're comparing the number 3, I is going to be equal to 1 and j is going to be equal to 3. Inside this for loop, we have an if statement, which is going to compare the index j of the array A to index I of the array A. So if the item we're comparing is less than the item we're looking at, we're going to swap the index values. We're going to run this snippet of code over here to swap the integers. We're going to run through this code over and over again until we finally reach a sorted list. So here's the actual C++ code. It looks quite similar like the pseudocode we were looking at before. Here we have our for loop, where we have an integer I, which is equal to 0, and it's going to run until we meet the size of the array -1. We're going to use -1 because the index number starts at 0. You have to remember that, otherwise you'll be off by 1. Here we have a placement, or a subholder, or a placeholder, sorry, for the smallest integer's index. And here we have our second for loop. Inside this for loop, we run the if statement, where we compare the item we're looking at to the item right next to it. And once this is done, it's going to run the swap, just like our pseudocode. Now let's try it out with the code. So here we have our C++ program. As you can see the code, we have these includes here, IOStream for our input-output, fstream to read the file with the numbers, and print out a file, and ctime so we could time the efficiency of the sort. So let me just fix this here. So here we have our f streams, in file and out file. These are going to be our input file and output file. This if statement is going to give us an error if we can't make a file. Other than that, here's our sort that we have seen before. Here we have a while loop where we count in, or where we bring in each number from the file into the array, and here we print out each number into a separate file. So here is our random.txt. This text file contains about 10,000 numbers. It contains 10,000 numbers actually, of random numbers from 1 to 1 million. And it's going to create, and these are the numbers that are going to be read into this program. So let's build this. It'll take some time. There we go. So as you can see, it took about 650 milliseconds. And now we could check out the sorted file. As you can see, all these numbers are sorted. So there we go. Awesome.